Hi, my name's Dr. Christopher James Ward from the Kansas University Medical Center, KUMC. Today I want to talk about ion exchange chromatography to purify N-hydroxysuccinimide dye labeled immunoglobulin. Now, in the previous talk, I coupled an IgA monoclonal 2D11 and an Ig2B monoclonal antibody 9D5 with two different NHS dyes. We used an AZ dye 568 and an AZ dye 647. Now, as you remember, these dyes have sulfate groups on them and are therefore negatively charged. Now, the idea is that you now have immunoglobulin, which is quite positively charged, and then you've got labeled immunoglobulin, which has a more negative charge because of the attached dyes. And then you have the free dye, which is intensely negatively charged. So what we want to do is we want to use anion exchange to separate these free moieties. So in ion exchange, you've got a positively charged matrix. In this case, we're using a strong ion exchanger. And that just means that the matrix is positively charged for a large pH range, from about pH 1 to about pH 11. And of course, because it's positively charged, negatively bound charged things will bind to it. So the plan is that we want to have a pH at which unlabeled immunoglobulin goes through the column and is not bound. Labeled immunoglobulin is bound to the column, and the dye is very strongly bound to the column. So pH scouting showed that a pH of 8.3 was required to get labeled immunoglobulin to bind a high prep Q XL 1610 column. Unlabeled protein flows right through, and the labeled immunoglobulin is retained on the column, and it elutes at a low salt concentration, and the dye, the free dye, is then eluted at a higher salt concentration, so you can split all three. And we want the labeled immunoglobulin. So how did we do this? So we take the QXL 1610 column and we wash it with 5 column volumes of 100 millimolar trace pH 8.3 in 100 millimolar salt, sodium chloride. Sample is loaded in a 0.5 ml loop, flushed onto the column in 1.5 mils. That's 3 volumes of the loop. And then we wash, and then with 100 millimolar salt, and then apply a linear gradient of 10 column volumes from 100 millimolar to 2 molar sodium chloride in 100 millimolar trace at pH 8.3. The fractions are 10 mils. So under these conditions, as I said, the unlabeled protein flows through. The labeled protein comes off at fractions 6 to 9, and the dye has a long smear from about fractions 11 to 16. We then equilibrate the column in 2 molar sodium chloride, 100 millimolar trace, pH 8.3. This removes all dye and immunoglobulin. Then we wash the column into water with 5 column volumes. Then we wash into 20% ethanol and water for storage. So what do we get? So this axis is the optical density at 2880 nanometers. So this is in the ultraviolet, and it's proteins absorb at this frequency. So we loaded here, and the unlabeled immunoglobulin went running straight through, and you have this nice peak that comes straight through at 100 millimolar salt. We wash with 100 millimolar salt, then start our gradient, conc B, which goes from 100 millimolar sodium chloride to 2 molar sodium chloride at pH 8.3. And as you can see, the conductivity goes up as well. This big peak here, 6, 7, 8, is the labeled immunoglobulin, which overlaps to some extent with the free dye. Now you can't see the free dye on this because it doesn't absorb at 280, but it comes off as a smear beyond this higher higher fractions. So we pull 6 and 7 and maybe 8 and we concentrate them. So how do we store them? So the fractions with the labeled immunoglobulin are again concentrated with a ultra 50 kD cut-off filter, and then we store in 25% trehalose and store at -80 degrees. So we'll have 2 or 3 milligrams of labeled immunoglobulin, which should be enough to keep us and everybody else happy for a long period of time. Now we'll go into the lab and we will actually do a practical and show you how to do this on an Acta. So this is an Acta Pure 25M1, okay, setup. And what we're going to do today is we're going to do ion exchange on our labeled proteins. And so we've got immunoglobulin, which is directly labeled with a fluorophore. We have unlabeled immunoglobulin in that mix, and we've got free dye. And so what we're going to use is this high prep QXL 1610 column to separate them. And so what we're going to do is first we're going to just flush the lines with water, and then we're going to prime this column with 100 millimolar salt, sodium chloride, in trace at pH 8.3, and then we're going to then load our immunoglobulin mixture, the label, onto the top of the column, and you can see there's a little bit of dye still stuck here from the last run. And then we're going to do a linear gradient over 10 column volumes and take it up to 2000 millimolar sodium chloride and 100 millimolar trace at pH 8.3. And what will happen is that the unlabeled immunoglobulin will go straight through into the waste. The labeled immunoglobulin will be retarded on the column, and it will come out in fractions about 6 and 7. And then the dye will come off after that. There's another peak. Now what we'll do is we'll collect 10 mil fractions, and as I said, the immunoglobulin should come out in 6 and 7, and the dye should come out roughly 9, 10, 11. Alright, so that's basically what we're going to do. So the first thing to do is just get the lines out from ethanol and put them into water. Now with 2 of the lines, one of them I'm going to put into the B2, I'm going to put into the 200 millimolar salt, 2000 millimolar salt, and A2 I'm going to put into the 100 millimolar salt. So A2 will go onto the column first, then it'll be split in a linear gradient with this right up to 2 molar salt basically. So we'll set that up right now. So what I've done here is I've put B2 into the 2000 millimolar salt and B1 into 100 millimolar salt. Everything else is in water. And I did notice one thing, there's some bubbles in the B2 and the B1 lines, so I'm going to get them out. And the way I do this is I just put a syringe in here, down here, open, and then try to do this one-handed here. Okay, so I'm just going to suck here. So okay, I'm going to open a new project here, and I'm just going to use a high prep QL 1660. It's what I'm using, and I'm just going to run that this program. And so what it'll do is it'll flush the whole system with water, and then it will prime the lines with the 100 millimolar salt and the 2000 millimolar salt, and then it'll ask me to put the sample on. I'll put the sample on and then start it, and then it should run and we'll collect fractions. Okay. Hi, so here is the 9D5 monoclonal, that's to polycystin 2, so G2B, and it's been coupled with AZ dye 647. So what we're going to do is we're just going to take this guy and put it into a syringe, and then we're going to inject it onto the machine. So I took the antibody up in the syringe and I put it onto this adapter here, which we're now going to put onto the machine. So just put a little drop on the top, and then we're going to put it in the machine. Alright, so I put the syringe into here, screwed it in. Here's a 0.5 mil loop, 500 microliter. The column, the QXL 1610, is being equilibrated with 100 millimolar salt at the moment, and once that's finished we'll inject and we'll start the run. Okay, it's asking me to load my sample, so we'll do that right now and then we'll continue. And what will happen is we'll load it into this loop. Sure. So we'll load into this loop here. Okay, I'll do that right now. Okay, done. And confirm it and continue. Right, and so what will happen is it will flush it through this onto the column. We'll see that in a minute. So there's a little bit of dye still up there. It's not going anywhere, so we'll just leave it. In a minute we'll see. Yeah, you can see it coming on now. Real time, really. There it is. There is our immunoglobulin going onto the column. And this column is at 100 millimolar salt at the moment. So we'll wash it through for a little bit, and then we'll put the gradient onto it. And we should be able, so what will happen is that as we wash it, the unlabeled immunoglobulin will go straight through, and we'll just forget about that. And then we'll get separation between the free dye, which will be at the top of the column, and about halfway down the column will be our labeled immunoglobulin, and it will come off in fractions 6, 7 and 8. Okay, so there you have it. Right here we've just switched over to the gradient, and as you can see you begin to get a split here between the dye and the immunoglobulin here. There's a little bit down here as well. We've got a bit of a leak, but let's just leave it. Okay, we're at about fraction 5 here, and we're just putting on the sodium chloride gradient, and you can see we've got a little bit of a leak. Leave it, don't mess with it, alright? Here is the dye, and here is the immunoglobulin, alright? So this is only a couple of microliters a minute, whereas we're getting about 5 mils a minute in the fraction factor over here. Easily, just dripping away in there. So we can get down, you can see it. Cool, eh? Really love this machine. So here is, we're about fraction 6. You can see the immunoglobulin's here, free dye is up here. So this will be coming off soon. It's a nice split between the dye and the immunoglobulin, so we should be alright. Very slight leak here, but it's not 5 mils a minute, which is what we're getting off the other side here. So hopefully this will be good. So this is 9D5 IG2B, which is to polycystin 2. Now, it's a good antibody for proximal tubule cells. Okay. Hi. So what we've got here is we've got our unlabeled immunoglobulin came off, went straight through the column. We start to put a salt gradient on this, the conductivity goes up. And what you see is this is our labeled immunoglobulin, and this is the dye. So we really want 6, 7, maybe 8 but we'll check 8, see if the dye goes through the filter or not. Okay, and then 9 and 10 and 11 will just, well, that's for waste. Okay, here we have the immunoglobulins here, and you can see this is 6 and 7, and there's very little free dye in the bottom here. This is number 8. There's just a little bit here. I think we can get away with actually pulling these two guys together perhaps, and using them in experiments. So what I'm going to do is concentrate them right up to about 1 mil, and then we'll split them with 50-50 with 50% trehalose to make them 25% trehalose, freeze them. So here we have them again, they're almost concentrated. You can see there's a little bit of free dye in this one, on the one on the right. I think that will be okay. So what we'll do is we'll concentrate them up to about 0.5 mil each and pull them and then put them in with trehalose, make them 25% trehalose, freeze them.